Hello students, very good afternoon to all. Hope you are doing good. So today we are going to do the determination of relative density of questionless soil as per Indian Standard Code 2720 Part 14 1983. So what do we mean by relative density is? Relative density is defined as the ratio of difference of void ratios of questionless soil in its looser state and the natural state, which is Emax minus E minimum. Emax is the value of void ratio when it is in looser state, and E is the natural void ratio, you can say, when soil is in natural state. To the difference between the void ratio in its looser state and the denser state. Emax again the same means the void ratio when the soil is in looser state, E minimum when the soil is in denser state, equal to relative density determines the compactness of the questionless soil, and the questionless soils are gravels and sand. So it's represented by ID, which is equal to E max minus C. E max is the, again I'm going to repeat it, is E max is the void ratio when soil is in looser state minus E when the void ratio if soil is in natural state, divided by Emax minus C minimum. Emax again the void ratio when soil is in looser state minus the void ratio when soil is in denser state. So there are some apparatus required to perform this experiment. So these are cylindrical mode. Its internal diameter is 15.2 centimeter and its height or depth you can say that is 16.6 centimeter. And Scholar dial gauge with the stand, circular plate, surcharge weight, your soil sample, or you can say questionless soil, which is sandy soil, and vibrating table. So let's see how to perform this experiment. So first of all, you have to empty weight the cylinder and note into your observation sheet, which is nothing but 10,512 gram, which we are recorded at W1, empty weight of mold or cylinder, you can say. Now measure the dia and the depth. You can use specifically you have to use vernier scale. For simplification here I am using the normal scale. You have to measure the depth and the dia of mold and write it down into the observation sheet, which is diameter comes out to be 15.2 centimeter and depth is 16.6 centimeter. Now fill the cylinder by using the soil sample whose density we have to find out, and level it and remove the extra soil by using a leveler or any scale, or you can and weigh again and note down that weight, which comes out to be 13,836 and it is W2 gram. Now bring this that mold and place over the vibrating table and tight that mold by using the screws. Make sure it should be tight enough. So while vibrating, it should not be moved. Now place the plate over the sample and now bring the collar and again it's placed over the cylindrical sample in which we put the soil, and again it's placed centrically and tight its screws by using tightening screw. Check all the screws should be tight enough. Now place surcharge weight over the plate by through the collar. Now on the vibrating machine, continue vibrating until 8 to 10 minutes and stop vibrating after 8 to 10 minutes. Take out the surcharge weight and remove the collar by loosening the screw. As you can see, already soil compaction has been take place due to the vibration. This is the dial gauge that we inserted, and initially record the reading, or you can make it 0, and which the reading is approximately equal to 44.70 mm. And smaller reading, the larger needle, you can see placed like this. So larger reading complete one circle, so it means it's equal to 1 mm. Its least count is 0.01 mm, and smaller will give you the one revolution equal to one digit movement of a smaller needle. Now drop the needle to the bottom over the plate and record again the reading, and which is nothing but approximately equal to 22.91. Initial reading over the top of the that mold. After vibration, that reading is noted, which is 21.79 mm, and drop height after compaction, which is nothing but difference of initial and final reading, which comes out to be 22.91 mm. Now take out that plate also, which is also included into thickness, and you can see and measure its thickness. So that we also add, because it's also depressing drop of height basically. So measure its thickness and note down into the observation sheet, which is thickness of plate, that is 1.2 centimeter, nothing but 12 mm. Total drop, the dial gauge reading plus the thickness of plate, which goes 22.91 plus 12 mm, comes out to be 34.91 mm. Now bring all the values into the observation sheet. There we need to calculate all the values. So put the value of thickness of disc or plate you can use, that is 12 mm. Reduce the height of sand after compaction, that is the total height you have to use. This was 34.91 mm. Now calculate some values, which is volume we required. Minimum density of sand is nothing but loose sand by the volume of mold. That's why we have to calculate volume first, which is nothing but area into height, and area is nothing but pi by 4 d square. Put the value of dia and the height, you will get the volume of the mold. Or initially mold and sample height is same, that's why I'm just considering the value of mold here. So weight of loose sand, basically the W1 W2 minus W1 divided by the volume, you will get the minimum density when soil is in looser state. Now calculate the new volume or reduced volume. After the compaction, height of sample is reduced, volume of mold remains same. Now we need to consider the volume of that reduced sand. So which is dia remains same, but height is now reduced, which was initially the height of that sample or mold was 16.6 centimeter minus 3.491 centimeter. That reduced height, you have to minus that value, and after that calculate the volume. This value of volume is coming out. Now maximum density is nothing but weight of sand. The weight remains same, volume is reduced, divide by that reduced volume, you will get the maximum density of that sample. It's coming out to be 1.39 gram per centimeter cube. So initially reading minimum density when soil is in looser state, means void was maximum at the time, and after the compaction void is reduced, density is increased. You can say here that relation between the void ratio and density is inversely proportional. As the density increase, volume of voids or voids will reduce into the soil sample. So that's how you can calculate the values. So on the basis of relative density, we can divide into some categories here by the using the relative density, and we have state of compactness. If value comes out to be 0 to 15 relative density, in that case we can say our soil is in very loose state. If it is in 15 to 35, it's a loose state, and value between 35 to 65 it is medium dense, and 65 to 85 it's a dense soil, and 85 to 100 is a very dense soil. So this is all about the related to the relative density, how to check what is relative density, each and every aspects we already seen. So thank you guys, take care.